Welcome everyone to the California Coastal Resilience Network webinar series. Let's just wait a few moments to allow people to join. If you're just joining us, we're just waiting a couple moments to allow people to join, and then we'll get started. Okay, I think we've reached critical mass, and let's get started. Again, welcome everyone to the California Coastal Resilience Network webinar series. My name is Nina Monk, and I'm the facilitator of the network. I am also a 2026 California Sea Grant State Fellow at the State Coastal Conservancy in the South Coast. The California Coastal Resilience Network promotes knowledge exchange through webinars on climate-induced impacts on human communities and coastal habitats. This webinar is being recorded and will be available to watch on our website along with previous webinars. Links to those will be included in a follow-up email that I'll send out after today. The timeline for today is roughly a 25-minute presentation, followed by the remaining time within the hour for Q&A discussion. During the presentation, please remain muted, and if you have questions, you can write them in the chat, or once we get to the Q&A, you can use the raise hand feature and wait for me to call on you for your question. Today, we have a very exciting webinar for you, the California Artificial Reef Program Plan. The interest in using artificial reefs for a wide variety of purposes continues to grow in California, and while traditionally artificial reefs were narrowly focused on increasing fishing opportunities, more recently artificial reefs have expanded to include additional goals and objectives like climate resiliency and restoration. Today's webinar will discuss a brief history of artificial reefs in California, key concepts emerging from the California Artificial Reef Program Plan, and discuss how focusing on building ecosystems with artificial reef projects can produce multiple benefits for both nature and people. Today's speaker is lead author of the California Artificial Reef Program Plan, Cindy Dawson. Cindy is a senior scientist at the California Department of Fish and Wildlife Marine Region. She leads the California Artificial Reef Program Plan development process, currently underway to develop a statewide programmatic. Just pause for a second because I forgot to share my screen. That's so silly. Bam. She leads the California Artificial Reef Program Plan development process, currently underway to develop a state programmatic guidance document to inform future artificial reef development. In her role at CDFW, her main area of focus is nearshore ecosystems, including rocky reefs, bays, and estuaries. She focuses on integrating emergent science into management decisions and filling research gaps to support sustainable management of nearshore finfish and ecosystems. With that said, I will now share this slide and hand the virtual mic off to Cindy for her presentation. And thank you so much, Cindy, for being here today.
Again, hi, everybody. Everybody seeing a slide?
Looks good.
Coming up? Okay, great. Well, thank you so much for everybody attending today. Thank you, Nina, and to the Coastal Conservancy for hosting this webinar and giving me a chance to talk about something we've been working on for quite a while in the department, the California Artificial Reef Program Plan. Before I begin today, I do want to just acknowledge my colleagues who have been part of the core project team, Leon Guo and Tanya Torres from the California Sea Grant Science Integration Team, and then Pike Spector at the Ocean Protection Council, who has been part of the project team, and they generously funded this work. Let's see if we can get the slides to go here. Hold on. There we go. All right. So before we launch into talking about the artificial reef plan, let's talk a little bit about what an artificial reef is. So we have a definition in California statute, and that was created in 1984. I'll talk a little bit more about that in a second. And it has some key elements. You'll notice that the terminology is a little bit dated, but it does point to some really key things that we'll need to remember as we go through the rest of this talk. So in statute in the state of California, artificial reef is something that is intentionally placed by humans in the marine environment. It can be man-made or natural objects. It needs to duplicate the conditions on natural reefs and rough bottoms so that comparison between a natural productive rocky reef and an artificial reef is something to keep in mind as we move forward today. It needs to induce the production of fishes and invertebrates, needs to stimulate the growth of kelp or other midwater plant life, and needs to create natural habitat. So some couple key concepts I want you to remember as we move forward today is this idea of duplicating natural conditions on naturally occurring reefs, and this idea of inducing biological production. All right, so let's go back a little bit in the history of how we got to where we are and why the state of California thought it was important for us to create a California Artificial Reef Program plan. So California has been in the business of experimenting with artificial reefs all the way back to the 1950s. We started experimenting with the placement and the study of artificial reefs in 1958. And those original reefs really took advantage of what we call now materials of convenience. You can look in the lower left of the slide and you can see some car bodies going in Southern California near Rincon. So we learned very quickly that a lot of those materials of convenience, like construction materials or car bodies that are made of metal or wood, or things like tires, don't make very good artificial reefs. Some of them degrade very quickly, and some things like tires are actually toxic. So that kind of building of those reefs kind of ebbed and flowed through the 60s and 70s, bringing us up into the 80s, when at the federal level, they passed the National Fisheries Enhancement Act in 1984. And there was a section in that act saying that we across the United States should be thinking about artificial reefs and thinking about what kind of role they could play potentially in fisheries enhancement. And so lots of state legislatures took action based on that federal law that was passed in 84. California legislature took action as well during that time. And that's when the California Artificial Reef Program was created in California. And it designated the California Department of Fish and Wildlife to administer that program. It was created in the 1984 legislative session. There was a one-time allocation of $500,000 to the program for the 84-85 fiscal year, and no sustained funding. Funding kind of ebbed and flowed in the 80s and 90s, and reefs were built based on funding availability. In 1990, the Department of Fish and Wildlife actually published what they called a state artificial reef plan. However, it was missing a lot of very key components. Primarily, it included the findings of the research from a couple of reefs. Pendleton Reef was one of them, and a couple other of the reefs in Southern California. And it missed really some key guidance around these things that we know drive artificial reef performance, like materials, siting, and location. So it didn't really delve into those things. It kind of just was like a high-level report of some of the early research findings. And so it didn't really like check the boxes of all the things we would really need in the state of California to help guide the placement of artificial reefs in a systematic and standardized way. So all of the building of artificial reefs that the Department of Fish and Wildlife was involved in ended in the 90s, and there is no dedicated department funding or staffing for the artificial reef program. So essentially, our role in actively building artificial reef ended by 2000. And so from that time on, we know that, and many of you are part of these discussions about what we would maybe want to use artificial reefs for in California, given current environmental conditions and the benefits that we think artificial reefs can provide to both people and nature. We know that there's been a ton of learning since 2000 about the nearshore marine environment and other marine environments. And this has all led to being a catalyst for us seeking funding from the Ocean Protection Council, which is one-time funding to support the development of this plan we've been working on for the last couple of years. So let's dive. Excuse me. Before we dive into the plan itself, I do want to just give you an idea. I want to just first acknowledge that this is a big caveat that we know lots of things have gone in the water that haven't been documented for the state of California. And what I'm showing you on the map is just where we actually have definitive records of reef projects going in. There were cities that made tire reefs. There were lots of other things that happened from the 40s and 50s onward that we don't have documentation of. But what you're seeing on the map is what we do know has been in the water. Some of these are quite recent. Some of the work that the State Coastal Conservancy and others have been involved in the San Francisco Bay. You can see that at the top of the slide. Here, where I'm in Santa Cruz, there was a reef put in the 80s off SoCal Point. Moving down to southern Central California at Tuscadero and San Luis Obispo. But you will see in the next slide that the bulk of the artificial reefs that have been created in California that we have documentation for is in Southern California. It is an interesting point that most of these reefs were created way before the California Artificial Reef Program was created in 1984. So only 14 reefs have been created since the program was created in 1984. So you can kind of see the ebb and the flow of the funding, and a big bulk of the stuff that was done before the 80s. Okay, moving on. So let's talk about the CART plan itself and what's in this thing and why it may be relevant to some of the things that you all are working on or interested in. So some of the key concepts that have emerged from the CART plan, and just a reminder that the CART plan is out for public comment, and we'll go ahead and drop a link at the end of this presentation so you all can check it out yourself, and you have till September 4th to send in your public comments. So I encourage you all, if you haven't read it already, to access it after this presentation and send us your comments. We're really invested in making this the most useful, accessible document that we can, so that people can actually have a resource that is going to help their future projects. So the CART plan itself really focuses on integrating the latest science on artificial reef functioning. I mentioned a little earlier that, over the years, obviously, we have improved our understanding of how ecosystems function and how habitat and the other ecological processes that go on reefs interact with each other. So we really leaned in hard to the science and doing a thorough scientific review. This was driven by a group of 11 technical and scientific experts. We called them the Technical Writing Group, or the TWIG. And I've been working with them for the last year and a half. with our partners, Ocean Protection Council and California Sea Grant, to put this document together and really ensure that this document was scientifically robust, well supported, as well as really accessible and understandable to a wide group of folks. So I mentioned a little earlier as well that one thing that emerges from the literature that is evidently clear is that there are kind of three main drivers that predict performance of an artificial reef. And that's the design, the materials, and the location you choose for your reef. So we organize the CARP plan around these three primary drivers of performance for artificial reefs. And then we also know that monitoring plays a huge role, and that our technical writing group especially was really interested in elevating the role of monitoring in the planning process for artificial reefs. Sometimes developers aren't thinking about monitoring until they get into the permitting phase. And we're really encouraging people that, just like in the very beginning, when you're making decisions about design, material, and siting your artificial reef, you should also be thinking about what you're going to monitor and what the goals and objectives of your reef are. I think the most important novel contribution, I would say, in the CARP plan itself is the idea of really centering and focusing on the foundational role of biological productivity and native biodiversity in project planning, and that all projects should start from that starting point and move out from there. And we'll talk a little bit more about how that actually happens in practice in the next couple slides. We also are very thorough about going over through case studies and literature review, both the challenges and the opportunities of artificial reefs. We have learned a lot about how artificial reefs function generally across the globe, but certainly in our own California ecosystem. You saw that map that we have a lot of reefs that have been down for varying amounts of time. And we have learned a lot, but there are still significant data gaps about how artificial reefs can affect regional production, or is it just localized, or how does it affect transport? There are open questions, and so we kind of go into those details in the plan itself. And then we hear, probably the thing I hear most often when I talk to folks who have been involved with artificial reefs is wanting to understand better their permitting requirements and the permitting process. And so we spend a significant amount of time in the later chapters of the document talking about who are the players and what is the process flow for permitting. And you can see a list of some of the main players. I do want to take the opportunity to point out that it's an interesting position that the Department of Fish and Wildlife is in, is although we have been designated by the legislature to administer the California Artificial Reef Program, we actually don't issue any specific permits for the building of artificial reefs. That is under the purview of other agencies like the Coastal Commission or BCDC, or others are the ones that actually issue permits for artificial reef construction. So where the department comes in is at the request of these other regulators who are actually issuing the permits for the construction of artificial reef, we come in and bring our biological expertise to species, habitat, and ecosystem, and help our sister agencies work through applications when they come at their request. So that's kind of how my agency fits into this rubric of permitting. Like I say, the plan itself has many more details. And I also want to point out that this is not everyone that may be involved with your project. The regulators and the folks involved in permitting are very location specific, but it's likely that some or all of these are going to be involved regardless of where your project is. And the last thing I want to say about the CARP generally is that the CARP very purposefully was project and species and location agnostic. So we made recommendations at a generalized level. So regardless of the goals and objectives of your project, this plan can really help you start down the path to develop a well-designed artificial reef that can maximize benefits and minimize impacts. So a little bit more about how the CART plan itself is organized. We have four main chapters. The first chapter goes over the purpose, the plan, what the plan is and what the plan isn't, and the definitions in history. So a little bit deeper about what we've talked to up to this point. I will say that the the purpose of the plan is to serve as a programmatic guidance document and to a resource for regulators and developers. So that's really what we hope to have achieved. And again, I'm hopeful that folks, if they haven't had a chance to look at it already, they'll be able to look at it after the webinar. So the second chapter dives into the existing science and how that applies to our temperate ecosystem here in California. And again, we leaned really heavily on the scientific experts to help us write and ensure that we have the latest and the greatest related to the science of artificial reef functioning. And of particular interest to you all, in the CART plan, we make a strong distinction between an artificial reef, where we ran over to the definition that has biological goals, versus other submerged structures that may have other non-biological goals like sand retention, shoreline protection. I'm going to talk a little bit more about that, but I did want to just point that out, that chapter 2, there's a section specifically talking about that distinction and why that is strongly supported by the literature. The third chapter, we go into those important drivers of artificial reef success, and we take them one at a time: design, material, siting, and then again, elevating the importance of performance monitoring and planning way at the beginning how that is going to fit into the overall plan for your development project. And then Chapter 4 looks at the best practices for artificial reef development, and it's really anchored by these 4 case studies. And you can look at the bottom of the slide, see Wheeler North, or the San Onofre Nuclear Generating Station, Song's Mitigation Reef. That's been in place for decades now. So that was a good particular example for us to talk about both the challenges and opportunity of using artificial reefs in the regulatory required mitigation space, meaning that if a development project causes a harm, they need to mitigate for that harm and the potential role for artificial reefs in that space. So we have a whole section on this particular case study, and then we have another part of the chapter on mitigation and some of the challenges and opportunities there. We also went over the Palos Verde restoration reef. This is a really unique reef in California in that it was restoring rocky reef that was lost to sedimentation and landslides. So a true restoration versus more traditionally, artificial reefs are often placed on soft sediment and in a location where there's always been soft sediment. So this was a unique opportunity to look at what happens when you try to restore hard substrate that has been lost due to anthropogenic impacts like a landslide. We also go into the Giant March in San Francisco Bay that has multiple objectives, biological and physical, and we'll talk more about that in a second. And then a shipwreck, the Yukon, that has been down in San Diego for a long time. So these case studies really allow us to kind of drill down into what we've learned specifically here in California, and then how we're going to move that forward as we're thinking about developing reefs in the future. All right. So again, I just wanted to highlight why these general recommendations, even though they're applicable to any project that you might move forward, why it's a real innovation and why it's going to allow us in California to have kind of a best case scenario moving forward for any artificial reef developments, that so that we can maximize the benefits. So all of these general recommendations are building off existing guidance, and three of the main documents that I want to call out are the National Artificial Reef Plan. Remember, I mentioned the National Fisheries Enhancement Act. It actually required the federal NOAA to create a National Artificial Reef Plan. So there was an original one in 84. It was updated in 07. So the CART plan in California aligns and builds off the National Artificial Reef Plan. There's also national guidance on marine artificial reef materials. And again, the CART plan aligns with that. And then a document that really, if you look at artificial reef plans from other countries and some of the states here in the United States, this London Convention and Protocol for the Guideline and Placement of Artificial Reefs is really this foundational document. So we align with these documents and build off of it and focus it on California specific needs. So the materials, we obviously inert, non-toxic, and durable. We also make space for novel new materials and how one might go about testing those. Design, we're asking people in California to build ecosystems. We want to provide benefits across life stages and species. We want to maximize connectivity when we're thinking about location. We want to move propagals both within a reef and between natural and artificial reefs. So that's something that we want people to be thinking about. And the monitoring has to be linked to goals and objectives, aligned with the variability, and it needs to be a driver of adaptive management if an artificial reef needs to make changes along the way. All right, we're going to end up with a couple cool illustrations here, and then we're going to open it up for questions. So we had a great scientific illustrator, Gage Hansen, work with us on the California Artificial Reef Plan. And what you'll see in the plan is this idealized artificial reef that really is focusing us on some of the key elements of a well-designed artificial reef. And those are heterogeneity, ecotone, dome, and halo. So let's take them one at a time. So what you're seeing in this slide is an idealized quarry rock reef. So quarry rock is placed on the bottom in a systematic way, showing different relief, so different distances off the bottom, different spacing among the quarry rock. And that's where we get habitat heterogeneity. And that just means like a lot of different voids and niches and reliefs that can support the whole community of a rocky reef. So some fish or invertebrates like holes or places to hide. Some fish or invertebrates like bigger spaces. Some live on top of the rocks. Some live in between. And so that kind of differences is really what we want to see in reefs, because we want the whole community, and the whole community has little habitat niches that we need to see in order on a reef in order for them to support the whole community and to build an ecosystem. So the ecotone, you'll see that's number 2. That's kind of right in the middle. That's kind of the transition between soft and hard substrate, or substrate types. We know from studies of nearshore rocky reefs in California that that sand rock interface particularly is a very productive area. And so having a well-developed ecotone and different types of habitats blending, so hard substrate blending into soft and then back into hard, those transition areas are really important. And that's something we really are going to look for in a well-designed reef. The dome is the area above the reef. We know from different studies around the world and in California that artificial reefs, because of the nutrient subsidies of the increased biological activity, the increase in nutrients can actually increase net primary productivity. And so that kind of area above can be a very active area. You can see in this illustration, we have blacksmith kind of in the background and senoritas, which are the little skinny yellow looking fish there, snacking on plankton and kind of to illustrate that dome effect. And then the halo is the area around the reefs. In general, in the literature, they say about 30 meters is an area that can be affected by these reefs. We likely think it's further out than that, but this is just showing you all of these components that are really important for a well-designed artificial reef. So let's move on from there and move on to wrap this up here. So one of the things that I've talked about so far today is this idea of centering biological productivity and native biodiversity, and then building out from there. And again, we have kind of an idealized rocky reef, an artificial reef on the left of the slide here. And we have very simplified arrows showing you some of these major biological and ecological processes like nutrient cycling. We have predation, we have grazing by both fish and invertebrates. We have shelter and food. We have the algae, which are providing that biogenic habitat. So in addition to the photosynthetic contributions that algae are making, they actually form habitat and food for other species. So we have all that happening when a reef is designed well. And we have both recruitment back to the reef. You can see the arrows at the top of the slide, as well as export away from the reef, whether it's to other modules, other stacks of reef in one project, or out to another natural reef. And then we push up to ecosystem services. And so ecosystem services is just a fancy way of saying direct benefits to humans. We get a lot of indirect benefits from a productive natural reef, but more direct benefits to humans fall under this category of ecosystem services. And particularly in the CARP plan, we focus on looking at research and education, fishing and diving, which has really been kind of a traditional focus of artificial reefs, was to increase fishing opportunities and potentially diving opportunities. We look at artificial reefs and how they may interact with shoreline protection, blue carbon or carbon sequestration, and then also talk about potential benefits to cultural heritage and tradition related to California natural or Native American tribes. And so this idea of a reef focus on biological productivity and native biodiversity providing additional benefits is really what we want to establish as the bar in California for artificial reef projects. And another way to look at this, and this is from Scotland, they have done a lot about thinking about the types of ecosystem services. And this also aligns with the United Nations and how they categorize ecosystem services into four big categories of provisioning, cultural, supporting, and maintaining. And so these are these more direct benefits when we think about what a productive rocky reef or a productive artificial reef can provide to humans. If you center biological productivity and native biodiversity, right off the bat, you're going to check a lot of those little pie pieces across all 4 types of ecosystem services. So you're going to create genetic resources. You're going to have benefits to fish and shellfish stocks in the provisioning. You're going to have nutrient cycling. You're going to have food web impacts and supporting. So you can see that across all of these different types of ecosystem services. And then you can think about designing your project and adding on additional benefits like potentially carbon sequestration or storm protection or recreational benefits or cultural heritage benefits. So we're going to end today on a cake because everybody likes cake, and walk you through an example based on Giant March in San Francisco Bay about how they centered biological productivity and biodiversity, but also were able to test a lot of other benefits while having a well-designed project with an experimental design that allowed us to learn a ton about artificial reefs. So, as I said, this project was in Ponol in San Francisco Bay, and it really focused on trying to understand how building a reef that centered biological productivity and native biodiversity related to native oyster ecosystem and communities could be tested in looking at different structures for the artificial or for the oysters to settle on, as well as how different elevations affected both the biological community as well as affected some of physical measurements. And they were interested in looking at wave attenuation and how these structures may absorb some of the wave energy. They were interested in looking at how these structures may affect the water flow and how eelgrass may settle and expand. They also looked at rockweed and how these structures could support that, and how rockweed would affect oyster populations. So a whole bunch of things balled up in there. There's probably people on this call who worked on these projects. There's a lot more deal in the CART plan, but I don't want to take too much more time other than to say they focused early and often on how they were going to monitor this and how they were going to do it in a scientifically robust way. And they were able to test a lot of things, but they centered this idea of a native oyster enhancement. And then they layered on what can we learn about shoreline protection? What can we learn about if eelgrass settles, how that might affect carbon sequestration? And it was associated with San Francisco State. And so there was a lot of students and others who got to work on this project. So it was able to have this layer cake approach of centering biological productivity and biodiversity, and then layering on. You could layer other things like cultural uses and recreational opportunities. All of this with this idea of really the central tenet of the CART plan, which is to center biological productivity and biodiversity. All right, so that's all I have for you all today. I would love to take questions if you have any. Nina will go ahead and drop this information into the chat, and I encourage you to go to the website, and that's where you can access the plan. You can learn a little bit more about what we've done so far, and happy to take questions.
Thank you so much, Cindy. That was a really great, thorough presentation. Thank you for tailoring it towards the members of the network as well. Okay, so I first saw a hand from Chris. Feel free to unmute yourself and ask a question.
We see you, but we can't hear you, Chris.
Should be able to unmute yourself.
Here we go. Got me?
Gotcha.
Yes.
Okay. Thank you very much, Cindy. That was a wonderful presentation. Just a quick question. I'm glad to see that our sea caves are aligning with much of what I see in the CARP. If if a project is envisioned as multifaceted with robust biodiversity and carbon sequestration and recreational cultural opportunities, but it's implemented in a targeted sea defense manner in the open ocean. This is excluding the bays. What does it fundamentally change how it's seen by the department? Is it categorized differently, different permitting, or is it just always seen as essentially as an artificial reef, or is it seen as a sea defense unit with artificial reef type components to it?
Yeah, that's a great question. And I think we as regulators are continuing to refine and clarify that for developers. Again, the department itself doesn't have a role in the permitting of construction, right? But I will say, based on the statute definition, if you I think that I know this isn't a Bay example, but I really think the Giant Marsh Project is a great example of where we learned that you know reefs that were the most effective at shoreline defense were not the most effective for oyster settlement. And
Mhm.
so that kind of learning really will inform how a project is viewed. And it really comes down to the goals and objectives of the project. And that's going to be the developer who is going to develop those and bring them to the regulators, right? They're going to say, my goal is this. You can have multiple goals. And if one of those goals is biological production and native biodiversity, and you're layering stuff on like the Giant Marsh Project, it will probably be evaluated under the artificial reef rubric. If your goal is shoreline protection, it will probably be evaluated under a different rubric. And I want to make sure that this group of people especially understand that the CAR plan doesn't make any statement on those kind of projects that focus and center non-biological goals. Those are going to be permitted under a different analysis rubric, and whether that project is called the artificial reef or not, it doesn't really affect whether that's going to be permitted by regulators. It's just sort of under the analysis rubric, it's going to be looked at in a different way. I mean, I can see a scenario where if my goal really was shoreline protection or to affect sediment dynamics as a developer, it might actually be in my benefit to not call it an artificial reef, because my biological monitoring requirements could be lower, because a regulator might decide, well, I'm not going to have them count everything 5 times a year because that's not what this was designed to do.
If I could offer follow up to that, though. So if you take, say, for instance, the San Clemente or Oceanside dogbone reefs, and if those are primarily sea defense projects, but if they were augmented with structures that were primarily meant for biological productivity, wouldn't the regulators and the public see it under a slightly different light, might have a greater chance of being approved or something like that?
I can't really speak to whether something would have a greater chance of being approved. All I can say is what the CARP really focuses all project developers, whether they're going to develop other submerged structures for a non-biological reason or an artificial reef to center biological productivity and native biodiversity, is that you need to be crystal clear about your goals and measurable objectives, making those quantitative, because that's what a regulator is going to want to understand is, are you going to meet those goals? Are you going to meet them in a prescribed time? And are those benefits going to be moved forward?
Thank you very much, Cindy.
Awesome. I just wanted to highlight Alex's comment and that she's grateful that the plan differentiates between primarily ecosystem serving reefs and reefs designed as coastal wave / energy barrier reefs in the plan. But that Cindy, you were saying that the general recommendations of the plan can apply to any artificial reef projects that are going in the ocean. That's correct, right?
Yeah, any artificial reef program, but again, if the project is really focused, and what we have learned from the literature right now is that projects that are purpose engineered for non-biological to affect sediment dynamics, beach retention, shoreline protection. If you engineer your project specifically for that, that's when they're most effective. Trying to do both lowers the effectiveness of both. So there may be a reason to lower the effectiveness of both because you want to do both. But if you really are focused on beach retention, say, engineering specifically for that usually will bring the best outcome. So I think there's just that dichotomy that the plan lays out. And again, it's up to the regulators whether they permit that or not. Like I said, I can see and I could envision a project where it might be beneficial to not be evaluated under an artificial reef rubric if that's really not what you're going for.
Mhm. Thank you. Okay, Nick, I see your hand is up.
Hey, good afternoon. Good to see you, Cindy and Nina. And
Thanks.
couldn't have been a better tee up, I think. And so a sort of related question, we're working on the Rebeach Oceanside project, and totally recognize, and CARP clearly lays out, the statutory definition, artificial reef, but also excited and kind of in line of what you just said, Cindy, of, many of those broader guidance around siting, design, baseline, post-implementation monitoring, and developing adaptive management approaches, locally and kind of for neighboring adjacent areas. We're following very, very similar to what's in there. So that's exciting to see, kind of following some. I think, and it's hard for me to not keep the Sea Grant hat on of just the opportunities. And if you know, down the road, are there any things you'd like to see, these reefs that promote shoreline protection opportunities that could test biological or ecological metrics or serve as a testing bed? Obviously we're kind of positioning as a pilot from a sand retention, shoreline protection point of view, but it also just seems like a missed opportunity if we weren't thinking about some of the ecological components and enhancements. And I'm just curious to kind of pick your brain and others on like, what areas do you see those gaps needing to be filled that could be filled by sort of adjacent projects than what the CARP is really focused on?
Yeah. Hi, Nick. Good to see you. Great question. So I think, I think the short answer is that our understanding as it lies right now is that those purpose engineered projects for non-biological tend to not provide the highest type of habitat, but it doesn't mean there might not be some ancillary biological benefits. And so I think it really comes down, a lot of this, comes down to the money available, the capacity available for a project. These projects are very expensive. Even small reefs are very expensive when you add on the monitoring. So I think it really comes down to the project developers and really their focus on their goals and objectives. And if one of their objectives for their project, even if the primary one is sand retention or some other kind of shoreline protection, if they want to understand what kind of benefits can we get, then certainly include that. I think what we're trying to establish is that it's going to be evaluated in a different way than an artificial reef, because if the primary design and material and location decisions are not driven by biological productivity and native biodiversity and maximizing those, then it's probably going to be evaluated under a different path. Again, the CARP doesn't make a distinction about whether, one is better than the other. It just says they're different and they're developed for different reasons. So I hope that is helpful.
Yeah, makes a lot of sense. And thank you for all the hard work on this.
Thanks for your question, Nick. Okay, so I have a couple more questions. Chris, did you have your hand still up or did you have another question? No? Okay. So Natasha, do you have a question?
Hello, thank you so much for having this presentation. It's really helpful. My name is Natasha. I'm from the city of LA. I'm not like um I don't have a huge environmental background. I'm kind of just like a general urban planner. So this kind of like lectures are really helpful in like understanding on the environmental side, how to plan. I have two questions. One, and this may be answered in the plan, which I'll look at later, but one, how is there any evidence or um to show like if like artificial reefs are really helpful in mitigating sea level rise, especially flooding? That's kind of one of the larger issues for my specific area in Venice, LA, the city of LA. One of our larger issues is not just kind of like water quality in the wetlands, but also potential sea level rise. So kind of understanding how beneficial is artificial reefs in mitigating sea level rise and flooding due to um, climate change. And then my second question is kind of um, in the realm of planning it out in the implementation side, like how much do this like artificial reef projects really cost, and from conception to like including the monitoring, and then what is the time frame from conception to like it being built? How long does that take?
Great. Thanks, Natasha. Those are all great questions. I'll try to take them in order here. So currently in the literature, there aren't really examples of where artificial reefs, as we define them, prevent flooding due to sea level rise. What they can do is provide shoreline protection and erosion protection, as well as mitigate storm surge. That's what the current data we have for artificial reefs as we define artificial reefs. Other places have include some gray infrastructure stuff, like essentially like underwater seawalls, or seawalls that come right up to like right below like high tide levels. That would not be considered an artificial reef in California. And I think I'm not as familiar with those, the performance of those. So the short answer is no, not really for sea level rise, but some of the other climate impacts like storm surge and increased erosion because of that storm surge. We do have examples, and that giant marsh project, which Marilyn put in the chat there, they actually modeled the percentage reduction in shoreline erosion that they got from that project. So there's a real world example there for you to check out. So timing is totally project specific. I think that the hope is that this will be a resource for both regulators and developers to kind of create a more systematic and more transparent process for developers. Traditionally, it has been years from conception to permitting, anywhere from 5 years to 10 years to get something from conception built. Our hope is that this document will help reduce that significantly. And cost is really project specific again. It really depends on the material, sort of like the costlier material that folks use is quarry rock. That can be incredibly expensive. There are purpose-built structures like Chris's Fish Reef project in Goleta, and reef balls is also, you saw those in the Giant Marsh project, which are There are forms that you can get from the companies and create pH neutral cement, or you can use Baycrete, which uses kind of natural sand and mud to create the structures. So, and the costs of those are all over the place. So I couldn't really give you a dollar amount.
Is there like a range from like the projects that you usually see from like least to most expensive?
You know,
Like a ballpark?
I actually can follow up with you. The most recent one with quarry rock, which is
Mhm.
like the
The
higher
most
end
expensive.
material, is
Yeah.
Palos Verdes, and I can get you a direct, like how much they spent on that project. So
Oh,
at
that
least you
would be
have a
really helpful.
ballpark of like at least what the high end is. And then if you want, I'm sure that you could contact Chris and he could give you information about exactly the costing for the sea caves that he used for his pilot project in Goleta Bay. So yeah. Oh, there. Uh,
Thank you
there's
so
Chris's
much.
email. Yeah.
Thanks for your question, Natasha. Yeah, if feel free to the email contact I dropped in earlier would go to you, Cindy, right?
Yeah,
Okay,
and
great.
if there's any follow-ups or folks think of questions after the fact, please just hit that artificial reef at wildlife.ci.gov. That goes directly to me. And so I'll get back to you with anything that I wasn't able to answer or if anything was unclear.
Awesome. Okay, we have another question from Ellen.
Hi, yes. So part of the CARP is creating a permitting framework, and I am just curious about what the role of the permitting agencies has been for this plan. Like how much involvement and buy-in has there been from the permitting agencies like Coastal, in terms of like the general recommendations, the agreement with the foundational role of biological productivity and biodiversity, also some of like the regulatory hurdles that we've had in the past, including the implications of fill, and also the idea of putting artificial reefs in areas historically that have not had rocky reefs in the past. And kind of going back to your idea of like maybe hopefully this plan will get us to a point where it's not many years from conception to actually getting something in the water. So yeah, just curious about the involvement of the permitting agencies.
Yeah, so I think there's quite a few folks from the agencies that are on the call today, and they've been pretty deeply involved from outline onwards. We had two internal review periods for the agencies, one at the beginning of the year and then one right before it was released to the public. So all those key regulators had a chance and weighed in actively about ensuring that the language we use aligns with their mandates and regulatory authority, and that we conveyed their regulatory authority appropriately. We knew, given that we really wanted this to be a resource for both developers and regulators, we knew that we needed to be talking to regulators throughout the process, and we were. So we feel very comfortable and excited about the level of involvement of the regulators, because we think that's going to allow us to achieve our goal of providing a useful, accessible resource for both project developers and regulators that they can actually use to make their job easier or support the development of a well-designed artificial reef. And the last thing I will say on that is that, you know, the intent of the CARP plan is to set the bar high in California. We feel that the science strongly supports really being thoughtful and holistic about how we think about artificial reefs, why we're putting them in the water, and what are realistic goals and objectives, measurable objectives that can be achieved. So with that, I think do we have time for any more questions? Or I think we're done. It's 1 o'clock.
We're just at time, yes, just at time. So I'll wrap things up. Thank you, Cindy, for preparing this presentation and being here today. Thank you to everyone for taking the time to listen. I will include Cindy's email in my follow-up email to you all if you have additional questions, including a link to the recording of this webinar. And yeah, thank you again for attending, and have a great rest of your week, everyone.